Welcome friends to this lecture. Today we are discussing regarding bricks. In this lecture we are discussing the various aspects which are associated with bricks. Some contents are this today's lectures are definition, constituents of a good brick, size of bricks, characteristics of good brick, manufacturing process, classification and some technical terms associated with this. And in coming lectures we are discussing regarding the bonds in the bricks. The artificial material of construction in the form of clay bricks of uniform size and shape are known as bricks. Size of brick. Traditional brick that may comprise of a size of 23 cm by 11.4 cm by 7.6 cm. That again differ from place to place. IS standard or modular brick that comprises of the dimensions 19 cm by 9 cm by 9 cm. What are the constituents of a brick? Silica, alumina, lime, oxides of iron, magnesia. Silica. Percentage of the silica in the brick that ranges between 50% to 60%. What is the function of silica? It prevents brick from shrinkage, cracking and warping. If it is used in the excess percentage, that makes the brick brittle and useless. Alumina. Percentage is 20% to 30%. Its function is to absorb water and imparts plasticity to clay so that it can properly mold it. If it is used in excess, it may shrink and warp the brick during drying and burning process. Lime. Percentage is that should not exceed 5%. Function binding particles together. It allows sand to fuse or to melt during the burning. Effects. If it is used in excess, it may cause brick to melt and lose its shape. Oxides of iron. Percentage is 5% to 6%. Its function is to impart the color to the brick. It helps to fuse lime and sand during the burning, binds a particle to give hardness and strength. If it is used in the excess, it makes the bricks becomes dark blue. Magnesia. Percentage is about 1%. Function is to decrease the shrinkage, gives yellow tint to the brick. Effects of if it is used in the excess, it may decay the brick. What are the characteristics of a good brick? Brick should have sharp edges. Brick shall not break into pieces when dropped from height of 1 meter. Brick shall have low thermal conductivity. Brick shall be soundproof. Brick when broken shall show homogeneous and uniform compact structure free from voids. When soaked in water for 24 hours, brick shall not show deposit of white salt when allowed to dry. Brick shall not have crushing strength less than 55 kg per centimeter square. Now let's see the manufacturing process of bricks. It comprises of the various processes. First one is the starting from the preparation of clay or brick earth. In that, unsoiling to remove the impurities of organic matter in topsoil up to 20 cm. Digging, clay is dug out and laid on a leveled ground a little below the general surface. Cleaning, stone, vegetable matter it is removed. Weathering, cleaned earth is sprayed and exposed to the weather for few months. Blending, mixing of clay, sand and other material. Tempering, the water is added to the clay and it is kneaded. Then again the molding process that may be of a hand molding process or a machine molding process. Drying of the brick it is for 17 to 14 days and thereafter the burning oil is carried out up to 700 degrees Celsius to 1000 degrees Celsius. Now, as we have seen already that hand molding also we have seen. So you can see the various wooden molds or steel molds are there. So mold are the rectangular boxes of wood or steel which are open at top and bottom. Steel molds are more durable and used for manufacturing of bricks on large scale as shown in the figure. Okay, bricks prepared by hand molding are of two types: ground molded bricks or table molded bricks. Okay, so we have seen those processes. Now burning of the brick is carried out in the clamp. Okay, so this is a very important operation in the manufacturing of brick to impart hardness, strength, and makes them dense and durable. Burning of bricks is done either in a clamp or in a kilns. Clamps are of temporary structures and they are adapted to manufacture bricks on small scale. Kilns are permanent structures and they are adapted to manufacture the bricks on a large scale. A typical clamp is shown here. Okay, so you can see the various layers of a raw bricks. Okay, and this is the earth which is covered with this. Okay, and to support this a brick wall in mud. Okay, and the burning is carried out. Now kilns, if you see, a kiln is a large oven which is used to burn the bricks by intermittent kilns and continuous kilns. Intermittent kilns, these intermittent kilns in operation, which means that they are loaded, fired, cooled and unloaded. Intermittent updraft kilns and intermittent downdraft kilns. These are the various types of that. Now we'll see a intermittent updraft kiln. This is in the form of rectangular with thick outside walls as shown in the figure. You can see these are the outside walls. These bricks are arranged inside of that. These are the flues spaces for that. Okay, and the space is kept for the fuel also. This is the door. Okay, for loading and unloading. Wide doors are provided at each end for the loading and unloading of the kilns. A temporary roof may be installed to protect from rain and it is removed after kiln is fired. Flues are provided to carry flames and hot gases through a body of kiln. Then next one is the intermediate downdraft kilns. These kilns are rectangular or circular in shape. They are provided with the permanent walls and closed tight roof. Floor of the kiln has opening which are connected to a common chimney stack through flues. Working is same as updraft kiln but is arranged such a way that in this kiln that hot gases are carried through vertical flues up to the level of a roof and they are then released. These hot gases move downward by the chimney draught and in doing so they burn the brick. Continuous kilns. These kilns are continuous in operations. This means that loading, firing, cooling and unloading are carried out simultaneously in these kilns. There are three types in the continuous kilns. One is a Bull's trench kiln, second is Hoffman's kilns and third is a tunnel kiln. So we'll see first Bull's trench kiln. So you can see here, you can see it is a arrangement is like this. Okay, in a circular or a oval format. Okay, and you can see the bricks arrangement. You can say the inner brick wall is there, outer brick wall is there. So dampers are also provided there. This is the chimney provided here. Okay, ramp of path is provided for the loading and unloading of the material. Okay, and these are the flue holes. So this may be a circular, rectangular or a oval shape. This kiln may be of a rectangular, circular or oval shape as shown in the plan, shown in the figure. It is constructed in a trench excavated in ground, either fully underground, partially projecting above the ground. Opening is provided in the outer walls to act as a flue holes. Dampers are in the form of iron plates and they are used to divide the kilns into suitable sections. Most widely used kiln in India. Next one is a Hofmann's kiln. This kiln is constructed over the ground and hence it is sometimes known as flame kiln. Its shape is circular to plan and is divided into number of compartments or chambers. A permanent roof is provided. The kiln can even function during rainy season. Figure shows plan and section of a Hofmann kiln with a 12 chamber. Chamber 1 is a loading chamber. Chamber 2 to 5 are drying and preheating chamber. Chamber 6 to 7 for burning. Chamber 8 to 11 are for cooling, and last one chamber 12 is for unloading. Okay, as you can see a circular is there. So 1 to 12 these are the chambers. Okay, so these are the flue holes are provided here. Then communicating doors are there in between. So at center you can find chimney there. Okay, so it is at sound foundation at bottom. Doors are provided here for the loading and unloading of the bricks. Okay, so it is a circular in a shape. In tunnel kiln, this type of kiln is in the form of tunnel, which may be straight, circular or oval in the plan. Raw bricks are placed in a trolleys which are then moved from one end to other end of tunnel. Raw bricks get dried and preheated as they approach zone of fire. In the zone of fire, the bricks are burnt to the required DQ and they are then pushed forward for cooling. When bricks are sufficiently cooled, they are unloaded. The kiln proves to be economical when bricks are manufactured at the large scale. At a temperature, as a temperature is under control, uniform bricks of better quality are produced. Then again, if you see the regarding the clamp burning, no control on the burning is there. Bottom bricks are overburnt, hence become brittle. Top bricks are underburnt, hence become soft. And if you see the kiln burning, better control on burning gives good quality of bricks. It gives better hardness and strength to the bricks. Bricks are of more dense and durable. Now, if you see a brick, what are the technical terms associated with this? And more details we are going to study regarding the various types of arrangement which are called as the bonds. So that we are going to study. If you see the brick, okay, so this is the length, breadth and height of the brick. If you see the IS standard brick, it is 19 by 9 by 9. This is a square is expected here. This side of the brick, okay, is called as a header, and the longer side is called as a stretcher. Okay, and at the top of that a depression is provided which is called as a frog. Generally when laying the brick in the construction, this frog is scraped outward, and when you are putting the mortar on the that is a mixture of cement and fine aggregate, that is sand, it is called as a mortar, which is a used to bind these bricks together, so which will get into this, and there will be a proper binding of the layers. So details again we are going to study in coming lectures. So thank you for joining this today's lecture. So in coming lectures we are detailed studying regarding the various bonds used in the brick making.